Good morning, everyone. It is Saturday, November 4th, at a variety of times of day, depending on where you are. We are here today joined with Dr. Amar Nayak, Professor of Strategy and Chairperson at the Center for All Interfacing Evolving System Science. And he's here today to bring us his topic, Resolving Water and Food Production Problems Through All Interacting Evolving System Science. Thank you very much for joining us today, and I'll hand it over to you for your presentation.
Thank you, Zen. Let me start the slides now. Is it visible?
Yes, it is.
Thank you. So good evening and good morning to all of you. A great day to all of you. I have to especially thank some of my friends and colleagues from different organizations who have joined. I must thank the International Society for System Sciences to have given this chance to share, both to me as well as my colleagues, to join you here today for this presentation. So the topic, as Zen already mentioned, is to look at how to resolve water and food production problems through this framework called the All Interacting Evolving System Science. So let me just briefly tell what this primarily, I know the key words or key aspects of this all interacting evolving system science, and that's what is going to be used to solve these two problems. So the first set of words or the main words that are important for this understanding is these words of interconnections, interdependence, interactions, and intent. In the literature on system science, we will of course find these words, mainly interconnections, interdependent, very often, and that's fundamental. And in some literature, we do see, and particularly in biological sciences, we'll see usage of word interactions very often. But it's true for all sciences indeed. The element of intent do, of course, get reflected by studies in philosophy and other sociological studies, and human interface with nature is when the issues of intent does come in. Now, these four words basically are, the first three relates to processes, which we see that in nature, and whether with human beings or not with human beings, this does occur. And the fourth factor, that is, or the fourth aspect, intent, is a factor through which we intervene. And this becomes more evident when thinking entities enter the space of the ecosystem. And particularly when human beings enter, then this factor becomes extremely important. That's the only factor, as per my understanding, as what makes the changes that we see or impacts the dynamicity in the changes that we see. So, so the very interesting part of these four is that intent is affected by the first three, and the first three also impacts the intent of the entity or the individual. That's the very interesting part of this four words, that they do interact with each other, and that they shape each other in different ways. So the first thing that we do in this approach to system science is we don't look at the questions, we look at the problem. We look at a complex problem. And that's many of the system scientists, of course, also prescribe to this, to look at the problem first, and then to look at the question or subsequent issue that you might like to look at. So what's the problem? And this problem, the approach that we follow is an ecosystemic and transdisciplinary action research to solve this problem. So it is, there are so many methodologies and methods, of course. Methodologies relate to philosophy of science and how do we look at science. That is captured in methodologies. But methods, of course, are independent. We can use different kinds of methods to approach a problem or an issue that we have at hand. Here we adopt both ecosystemic, a holistic view, as well as transdisciplinary and action research, so solving the problem. And why? There are, of course, several dimensions, as you might have seen in the short note, as well as the full article, of course, I had shared with Michelle, which has all the different dimensions that we consider when we look at ecosystems. But why agriculture in particular? What's the significance of this? This is a very interesting dimension, because this is the dimension where the nature and human beings have their first interface. So it's a very interesting area to look at, and then see how this logic that works in this interface can then be taken forward to understand organization, governance, or institutions, or social relationships, or any other subject, whether it's even physics or chemistry or biology. All this can, of course, be understood pretty well. So agriculture is in a domain where human interaction maybe has the largest number of years that we have had in the ecology is in agriculture. So it has a lot of significance and importance to understanding the changes in the phenomena that we see. So, so then coming to the problem, the first problem that we have for today's discussion is, of course, water scarcity. And this is the kind of situation that we look at when it comes to the Indian context. So this is the level of water stress across the country. For most part, we can see that it is either medium or very high extreme conditions of scarcity of water. Although we have an average of 1180 millimeters of rainfall, annual average rainfall in the country. That's around 120 centimeters of rainfall, which is a huge amount of water that we get. But despite that, this is the condition that we have in India. The second problem, of course, is this problem, the agricultural crisis that we have, not only in India, but across the world. This is a severe problem that we have, and it's very interesting to apply system science and understand how to resolve this problem. And this I would explain very quickly, or rather broadly, through this interconnected or these dynamic interactive cycles among the different production factors of agriculture. So here we can see some of it, whether it is cropping pattern or soil health or seeds or ecology and the source of water. So these are some of the prime production factors, and how do they interact in the industrial agricultural system? And what are the kind of risk they produce, whether it is climate risk or market risk or increase in costs? How does, so we see that the cost is far increasing. It's far higher as compared to the profit. So the negatives that you're seeing there are making the profit negative because of the either market risk or climate risk, or crop yield to begin with goes up and then goes down, or seed germination, regeneration of seeds, whether from the kind of seeds that we use. So there are several risks, and how does it impact the profits and how does it impact the cost? So this dynamic interactive cycle among key production factors shows that it leads to degenerative agriculture. And that is quite evident from some of this data that one can look at. That is the amount of subsidy the world over that governments give to agriculture. It is there in this website, one, of course, all of you will be quite aware of, the OECD website as well as World Bank website, where the OECD website shows the current annual subsidy across the world is $817 billion per annum. That shows the inefficiency of this production cycle that we have. So this is a huge problem, and this also has an effect on climate and several other aspects that we have. Food, nutrition, if you look at all the SDGs, this has a significant impact on most of the basic SDGs, both on ecological SDGs or environmental related SDGs or social SDGs or basic needs of communities. So we can see that this is really a huge crisis that we encounter, but this is the kind of imagination or the way I think how we have created this high subsidy driven or highly inefficient production system worldwide. So of course, when we look at this problem, then we have to, the way we approach is we look at the whole system as a whole. So that's what we say ecosystemic approach. So look at the various dimensions that impact each other. And they're just not linear dimensions, but they are highly embedded and interlocked dimensions. And of course, in today's, I won't go into the details of this, but in today's discussion, our focus is on agriculture. So that's one of the dimensions that we're going to look at. But we know that this cannot be understood without looking at the other dimensions, the market dimension, the organization, the institution, the production processes, the organization design, and all other dimensions that impact the production itself. In fact, every dimension, the problems within that dimension is not probably more than 20%, and 80% of the problems are outside that dimension. Then the system scientists would tend to typically think and figure out these issues. And that's true also in the case of agriculture. But for today's evening, we will look at agriculture. So likewise, one can actually go into the depth of the important factors. There are some 40 factors listed down against different dimensions here. And here, of course, we are looking at just the agriculture part. So we're looking at this particular dimension and the various factors and the variables of the nature of factors that we're looking at. So this being the set of factors, whether it is farm forestry or ecology that I referred to, or moisture or water or seeds, or basically genetic material, the stability of genetic material, whether it is plants or crops or livestock, what is the genetic stability of that material? So that's what I refer to seeds or soil system or the diversity or the cropping pattern in the farm. So one can look at this spectrum and say, if farm forestry is shallow on one end, it could be deep on the other end. So a lot of trees on the farm is one option. The other is no trees on the farm. The second is, of course, you get water from wherever you can, but you don't regenerate it. The other is, okay, you make the water, conserve the water in situ and make it renewable. The third option, of course, the seeds are, or the genetic material is exotic or unstable, and the other is indigenous and very stable. And the soil system, whether we make the soil system disabled or we make the soil system enabled, or live soil and dead soil is another way of looking at the nature of soil system that we want to consider. And of course, the fifth one is the diversity, whether you have high diversity farming system or a monocropping kind of farming system. So there are these different options that are available. These are the two extremes in each factor. But one can, of course, have a combination of different levels or different points of this spectrum. But these are the possibilities for a designer to think of how to plan production system. So now, our work here, the action research that we undertook is on these two counts. One is, of course, to look at how to conserve water and make water plentifully available for everyone on the farm. And the second, of course, is this cannot be studied by looking at agriculture as a whole by itself. So within the farm. So we are looking at these 5 features of these factors, or I could call the nature of variables, the nature of factors are all on the right-hand side. And we're also looking specifically on the case of water for today's discussion. So let's look at how, what are the criteria we're using. Of course, we'll have some criteria which are complex in terms of images or photos or very, very, complex factors. The other factors, of course, or the variables could be simple, reducible variables. So I look at some of this, just looking at farm landscape, how the farm landscape changes over time, or look at in situ water conservation and water availability on the farm, or soil health in terms of organic carbon, pH, and micronutrients in the soil. Climatic factors could be rainfall, the water conservation that is possible, carbon sequestration that's taking place, temperature that is changing on the farm, sunlight absorption, and wind speed. So we can look at these as the specific variables. And we can also look at the regenerativeness in terms of whether there is reduction in cost of operation on the farm. So whether the overall cost of managing the farm is coming down or the input cost is coming down. So whether there is a reduction in cost of operation. The sixth could be, of course, and most important one is the farm incomes, the income for the farmer from the farm. And of course, we've just completed a study supported again by NABARD, which is to look at the income of farmers across the country. We visited almost 20 states, out of which we got samples from around 18 states, and we have data for that. We will complement with our action research results as to what did we find in terms of incomes and how do they stand as compared to the normal farming practices in the country. Seventh, of course, we'd like to see whether if this is working, the other way to check is also whether it is replicable, whether it can be, has it been codified to be replicable? Second is it getting replicated? Is it being picked up by farmers? I mean, is it possible to even for us to replicate on our own on experimental basis? And of course, whether there is an impact on practice and policy, and that those are also indicators to see whether this is really making sense to people. And of course, based on our findings, we also have come up with the regenerative ecosystem designs. And these are all towards creating the lowest level of governance, or the gram panchayat we call in India, and similar kind of lowest level of governance exists across the world. We studied around 15 countries. They all have in different names, whether it is ward or whether it is GN or panchayat or union parisads, different kinds of names are there for different, the lowest level of governance. So at the lowest level of governance, is it possible to plan to create a regenerative ecosystem? So those are the kind of work that we are involved in. But we'll look at some of these as the criteria to assess how this experiment shows us to apply AIESS and see whether it gives us better results. So the problem one, the first problem was about water scarcity. So how did we do? What did we do? I'm going to show that quickly and and then the results out of that as well. So this was to make water abundantly available for all life and activities on the farm. The typical water requirement is seen is in typical, in Orissa, it's around 3 lakhs liters per annum per hectare. In Rajasthan, it would be around 5 lakh liters per annum per hectare if you're going this organic, climate resilient, regenerative agriculture. If you're going, of course, industrial, it goes to the tune of 60 lakh liters per annum per hectare. So that's the kind. So we want to make this water available sufficiently at the farmer's level. So this was the original condition of the land, piece of land that we got to experiment. The organic carbon here was 0.33. And this, interestingly, in 2016, was also the national average of organic carbon of soil in the country. You can see the quality of, these are some images to get a sense of what this, the condition of the land. This was, of course, we cleaned up, but still there is still enough garbage there. This is the kind of soil we have, and organic carbon I already mentioned. And we, of course, the first part was land leveling. I won't go into the details, all that we did, but I'll show you something that we did with regard to water conservation. So we did some trenching around the farm. There were ways of doing trenching. It's not very expensive, and there's a lot of soil that comes out. You have to deal with that soil as well. So we use that for leveling the land. And then, of course, within 15 days, as predicted about the monsoons in the country that year, 2016, 1st of January, there was a 6 centimeter rainfall. That's 6 lakh or 600,000 liters of water that dropped on this 1 hectare of land. And some of these we try to capture through these micro locks. Because the soil was poor, it is not possible to hold water in this kind of soil. But subsequently, of course, you have these trenches around, so it captures the water to some extent. But the same position in the second year was looking like this. So there's a different ecology that has come up in the same location. The water holding capacity had increased. The details, of course, are in separate papers, but it was holding water for 5 days. In the first one, in the first year, it was holding water for 2 hours. After that, it dried up. So these are other ways of dealing with soil. These are all taking care of the soil health. This is a green manuring of the land. There are some crops that are there, but there is also, you grow some crops and then cut it and put it on the soil. So you're green manuring the soil, once again, to take care of the soil. And of course, you're also making microbially rich solutions to add to the soil and to the plants. These are all to take care of the soil health. And this is primarily nothing, but primarily applying one aspect of system science, that is, the strength of a chain is the strength of the weakest link. So in this farming system, what is the weakest link, and take care of that weakest link, and that is this. So take care of the life below the land surface. So the microorganisms below the land surface. So this is the first step that was undertaken. And of course, there are other things. As I said, there are 4 other variables to look into, but this is the first step on taking care of some parts of some aspects of the soil care. That is to increase the largest number of species, the microorganisms below soil, and earthworm as an example, to improve their population. And that will subsequently lead to water holding capacity or soil porosity capacity. So the results, within first year, we saw there was a 700% increase in water holding capacity. And by third year, it was holding every rain drop that it fell on the land. So there's a video on the YouTube one can watch later. I can share the link later. So this is the well. It is in a city, urban area near to my college. So there's a very limited land. So this was the well. And what is important to note below is that in 2016, the well, the water in the well, this is a 40 feet well, open well. And in the heat of summer, that is the peak of summer, in 2016, the baseline year, the water column was 22 feet. In 2017, the same peak time of summer, it was at 30 feet water column. And of course, we were using water then more. We calculated we had used something like 2 to 2.5 lakh liters of water that year. So the average is around 3 lakhs that we use if you're growing crops throughout the year. But we had used 2 to 2.5 lakh liters of water. But despite that usage, still the column height was 30 feet in 2017, and 2018 it is 31 feet. And of course, there's always delta X improvement in the water column in this well. And of course, we replicated it in 3 other locations to see whether it is doable in other locations, in other topographic conditions, other land topography on hills, on the hilly region, on a hill. We did this. The water was at this kind of levels that we could achieve. At 22 feet in peak of summer, we could get water. This is, of course, in monsoon, you get water at almost ground level. This is the second replication, again on a hilly area, but the slope was high, not as high as the first one, but the slope was almost, the altitude was almost around 15 feet from one end of the field to the other end. And the water is, again, even at the peak of summer, is around 8 feet from the ground. So very high amount of water. And this is the third replication, another hilly area, but it's relatively flatter land. So the topography are different. And here, when the state declared the rainfalls to be in drought, the state was declared to be drought with 70 centimeter rainfall, we had this much of water in the farm. So it was showing us results that, yes, you can get lots of water, provided you take care of the other things that, as I showed you in the beginning. Problem 2. Let me just see the time. I may be taking a lot of time. Okay, a few more minutes. Problem 2 was about degenerative agriculture. So we did see the interactive dynamic cycle that leads probably to this degeneration. And this was the condition, as I already mentioned. This was showed you the initial land in May 16, 2016, the organic carbon 0.33. And this in 5 months, this piece of land in 5 months, this situation changed to this in 5 months' time. And of course, the things started improving from then on. From here, to here just in 5 months. And of course, in the second year, the cropping cycle was changed. We need to change that. The first year was the reason why we did that way, but we kept on changing the cropping cycle. And of course, the incomes were also important. So you can see one crop has come out, second crop has come out. And of course, this is a cycle that you can see different cropping. And by February, this had almost 35 varieties of crops in that 1 hectare. And the agricultural area was only around 2 acres out of 2.5 acres. We were farming on around 2 acres. The income of that year was around 198,000 rupees for the year. And then, of course, subsequently increased. I'll show you the figure subsequently. By third year, the landscape of the farm had changed to this. So you can imagine the first year's landscape, and by third year, the way it has changed. And of course, you can see there are fruit trees coming in. It has changed substantially now. We would like to make it a food forest, so the temperature comes down substantially. So this is the ecology. Within 3 years, the forest cover was also developed around the farm. This was an empty space, but in 3 years, there's a pattern of growing this. So this was also done, but there are some boxes, honeybee boxes there. These are important ones. So what we were doing, basically applying system science, is we were basically taking care of these two. Below the land surface was the microorganisms, and above the land surface was the flies or butterflies and honeybees to take care of them. And so your ecology is being designed and developed to take care of them. And this was the reason for increasing yields on the farm. So it has a very interesting phenomenon that take care of the weak below the soil and take care of the weak above the soil first. And of course, they're just not weak, but they're also very large in numbers. They have a huge role to play in the production process. So that's what we were primarily doing by all those other things. So let me skip through this. These are some of the other images of the farm that shows high production, high productivity, very good crops and no pest attack despite non-usage of any pesticides. These are all indigenous seeds. Yes, all genetically stable seeds. By year 3, this was of course part of the farm. We were growing all this throughout the year. Of course, lots of things there happening. Lots of very good demand for this crop because of the quality and nutrition. All these seeds were got from different parts of the country because these seeds are not generally available in the market. Of course, these again within 3 years, all these are milk is a big income from the farm. And of course, these are all, it's called ghee, honey, of course. So these are the figures that one can see. So water, as I already mentioned, by 2017, there was abundant, enough and more water. And it continues so far. Soil health, organic carbon, despite intensive cropping, we can see that soil carbon from 0.33 went up to 0.45, went up to 0.53, and currently it has gone up further up. 0.79, it has crossed 0.9 by now. But these are some of the figures that you can see. pH, again, we have to, because we're cropping intensively for incomes, we have to keep balance of all this. So pH, of course, going up and down, but it's stabilizing now. Micronutrients, yes, it has also improved. Depending on the crop, we consume all this. So every year we have to do soil testing to see what is to be filled in back. In terms of water, rainfall in situ, 700% increase, complete absorption, as I mentioned. Carbon sequestration, moderate to large to near total. No burning on the farm. Temperature, very interestingly, decreased by 2 to 3 degrees in the farm. In the first by 1 year, and by the third year, it further came down to 3 to 5 degrees. And it will further go down with our biodiversity increasing on the farm. The wind speed, clearly, it was fairly checked in 2017. We have cyclones on and off, and it's able to check now. There's little damage now, even if there is, moderate cyclone in the region. The cost reduced by 10%. Gradually, it has been reducing. It has reduced to 30% now. And the farm income, very interestingly, in the first year was around 250,000. In the third year was 360,000 rupees, which is almost 30,000 rupees per month. And it increased to 50,000 rupees per month. The hypothesis that we should be able to reach 40,000, which is 50,000 is 10 times the five times of the current household income, which includes not only agriculture, but other incomes of the family. But this is purely from farm income. If you include the other dimensions and stabilize the ecosystem, it can go to 10 times of the current household incomes of farmers or families in the rural ecosystems in India. So that's one of the very important figures. And we found across the country study that the figures of around 25 farmers that we studied, the figures are also averaging at 50,000 rupees per month per hectare net income, which is 5 times of the current national average, which is not only income from farm, but also other incomes for the household. So that's an indication of how it performs. And of course, replication, yes, we have codified as well as replicated in 3 districts. Farmers have begun to adopt. Very little is required once you show them how it works. And of course, design has been developed and projects have been initiated. And I must thank that a lot of support has come from NABARD. It is the National Bank for Agriculture and Rural Development. It's a nodal bank for agriculture in India. And also Rabobank from Netherlands has supported this, as well as Government of Orissa, Government of India, and several other entities. And most importantly, of course, the local communities and farmers who participated in making this possible. And of course, I must thank my own institute, XIM University, which has been, of course, very kind enough to allow the time and freedom to experiment in areas which, typically is difficult otherwise to get there. And so the factors and processes, I'll take, Zeni, how 5 more minutes is okay?
Absolutely. We started late, so please take your time. Okay.
So the factors and processes of this all interacting, evolving system science, if we had to understand that, in the case of course, agriculture, we saw these were the factors. Now, if you choose this set of factors, which is the industrial, typically I wouldn't say largely there is some modifications here and there, but broadly the industrial agriculture as practiced all over the world, or majority of the world, and the crisis that we see. If you're following these set of variables, or take this nature of the factors, among the possible factors that we have, we tend to end up into a degenerative agriculture. And we already talked about this. And so that this is probably the reason why the high subsidies are a reflection of inefficiency of this farming system. And this is now fairly understood, globally understood, that there is a problem in the farming practices that we have. On the other hand, if you take this set of, the nature of factors become this type, then we have another kind of dynamic interactive cycles that we facilitate. And that leads to regenerative agriculture. And the dynamic regenerative cycles that we create looks something like this, it takes some time to explain, but what it basically shows is that the ecology, the diversity, the soil health, the seed types, all those 5 are interacting with each other to create a balance. And actually, the nature takes over. Human interventions is just about managing, balancing a bit, overseeing the activities, but most of the activities done by the nature itself, whether it is soil health, or whether it is organic carbon, whether it is water, or whether it is pollination. The nature itself is actually, so you can see that there are these different cycles that are operating. As system scientists, it's very easy to understand these cycles. And of course, within that, one can see the link between soil health, biomass and manure, diversity and ecology. They also have, they are also interacting. And of course, the water case we saw is, I know the soil health will depend on soil. Soil health will depend on or lead to soil porosity. Soil porosity will lead to water holding capacity, so water harvest. And of course, that will further give you some biomass or grass, and that further adds the microorganisms. And of course, the biomass and manure is further adding to the microorganism population, and that is further increasing the soil porosity. So you can see that this is a dynamic, interactive, and regenerative cycles among the key production factors. But this was determined based on the nature of factors that we chose. This nature of factors, you just set it, it interacts, and it produces a result which is of this kind. So what we see is the solution, we end up in a regenerative agricultural system. And therefore, the summary, in short, what I think and share, and what I could reflect on looking at this, and which of course can be very well applied to other, and we are applying that to other systems as well, to organizations, to institutions, to local governance. So we are researching on all these different dimensions. But what we find is, if you have to look at the very ontology of change and epistemology of change, and in this case, the farming system, the farm itself, what is the reality of the farm? The situation of the farm keeps changing depending on the factors that you allow to interact. It keeps changing. Whether you change or not change, it'll produce something. There'll be some change. But how do you actually understand the reality of the farm? Is you understand through the interactive processes. And it is these interactive processes through which the farm actually evolves, either to degeneration or regeneration, or in between. So it's this simple intentionality which shapes the design factors of production, which then takes off to interact and produce the result that you might not have imagined. So that change occurs due to interaction of design factors of production, which are shaped by the intention of a farmer. And of course, this intention is also can be shaped by understanding or being conscious about the reality, how the reality operates. So it's about understanding the significance of interconnections, interdependence, and interactions. So this very awareness and knowledge, very deep knowledge of how they create change, would actually impact the intention of the individual. And of course, that this process of change is an ongoing, evolving process. And that is very well, of course, the biologists and evolutionary biologists have all very clearly articulated this phenomena when we look at how life has evolved on this planet. And this phenomena of the farm appears to be explainable through the all-interacting evolving system science. And with that, actually, I would end here. And thank you all for your patient listening.
And thank you. That was an engaging and interesting presentation that combines real-world examples of the use of system science to solve very, very important problems, water security, food security. That was really wonderful. I'm sure there'll be lots of questions and comments. And just so that I can plan the rest of our time together, Amar, are you able to stay past 8:30 p.m. or do you have a hard stop?
I will. I can.
You're able. Okay, great. So I think what I'd like to do is open up the floor to questions, and I'll monitor the chat. So please, if you have questions, put them in the chat. I know normally we do a roundtable, but there are quite a few people here, and I think that could take some time. So I'd like to give everyone a chance. So if anyone has any questions or you have to get going, please let me know. I can call on you first, and I'll keep an eye on the chat and see how things go. So I'll open it up to the group. Does anyone have any questions? You can raise your real hand or your digital hand. I think I can see everyone. Gary Smith, you have your hand up. Go ahead.
That's great, Amar. Thank you. It's really inspiring. Could you tell us? Thank you. Could you tell us a little more about your efforts at expansion? Spreading that philosophy, that way of working across other areas, both within India and potentially outside. I'm just interested in how things have been going.
Oh, yes. In India, of course, we with this much of studies, I was invited to advise the Ministry of Agriculture on what we call sustainable agriculture, or we call Paramparagat Krishi Vikas Yojana we had as a scheme for natural farming or organic farming. So it's picking up. I think now around 12 states or more than 12 states in the country have, of course, this is not the only work. There are lots of people who have been working on this, advocating on this. And almost 12 or 15 states have a policy on natural organic farming systems. But the science of doing it has improved. So in fact, today I got a letter from the state government to develop a training module, which is a program supported by the World Bank, to develop a training module to train farmers and officials and trainers on water harvesting system. Water harvesting in the state. So it's fascinating. I mean, I go to other states as well to get invited to go and show them how to do it. But on a government level, also it is actually picking up on water. On food, yes, the same thing. And we have applied. In fact, this study began looking at designing organizations, because I'm a professor of business strategy and business organization. So my work began by looking at how to redesign organizations, and not that it was not possible, as I mentioned to you, Gary, that to work with large corporations to make changes. So the design was to look at primary cooperatives and see if we can redesign them. And that has become our work on that farmer producer organization of primary cooperatives. The findings of that has actually, I was asked to write the national policy for the government of India on farmer cooperatives, and to put in place around 10,000 cooperatives in the country. So, so there is an acceptance. Of course, that all that you suggest always is screwed up a bit here and there because of the interest groups. But many of the features, I would say 80% of the design features have been accepted and it has gone through. Of course, they accept, but they keep changing because of other interests that comes in play. So this has become a national policy. It has been out there. We have been also working with the Ministry of Governance, Ministry of Panchayati Raj, so to look at how to create these local level units, local communities to become self-reliant. So wherein you work with water, you work with food, you work with marketing, you work with production processes, you work with all the other different dimensions that are there, as I was mentioning. So how do you make rules, regulations for the community? So all those levels have been taking place. Likewise, we have application on industrial clusters as to how to regenerate water, how to control pollution of water or air. But we had done with water already in industrial clusters, as well as in urban locations. So how do you actually deal with sewage water and drainage, rainwater storm drainage? So how do you deal with these water systems in urban area? And so we just use this biological process to actually manage water well. So it's it has a lot of application indeed. So.
Brilliant. Thank you for going more into detail on that. It's great. Love it.
Great. Thank you. Jamie has a question, and then after Jamie, I'll call on Marcus. Go ahead, Jamie.
Hi, Amar, thank you very much. That was a very thorough, I'm so happy to hear the great accomplishments that you've had there. I had a couple specific concerns. I'm assuming that most of the accomplishments planet-wise has happened after World War II, when most of the economies and concern was shifted to rebuilding. What percentage of the waters come from the Himalayas versus seasonal monsoons and other seasonal factors or precipitations in the lowlands? And what percentage of cost difference into each of those different efforts are involved? Do you have a breakdown on the cost percentage? And a third concern I had was, what percentage of farms are large commercial operations versus community and local personal family farms?
Yes, I got the third question more clearly.
Okay.
Let me answer that. We see that we've looked at the case studies across the country for different sized farm holders. So 200 acres and 100 acres to 50 acres to small holders. So 5 acres or 1 hectare, 2 hectare. So what we find is for the farmer to deal with this, because the diversity is too much, and the operational cost actually increases if it is going beyond 15 acres. The cost really increases. So your overall revenue can go up, but per capita earnings goes down after actually 2 hectares, because it becomes unmanageable for managing the diversity at a farm level. And if you start using outside labor, then the cost keeps increasing. But you can earn money, you are making money, but per unit or efficiency level is not higher. It goes down after a size of the land. So that's one of the empirical data that we find as we compare farmers across the country.
Oh, good. I'm glad you've taken that into consideration. Very good.
What were the first 2 points?
The sources of water, which percentage come out of the Himalayas and rivers compared to precipitation in the lowlands?
Okay, I won't know about the Himalayas. I have not kept data on that, but the average rainfall in India is 118 centimeter, which is almost per hectare we get around how many? 118 lakhs or 11.8 million liters of water per hectare.
Has that changed over the decades? Has the amount varied, increased or decreased?
This data is fairly stable for the last 30 years. So what we are saying is, if you have 40 centimeter of rainfall, you have 5 times or 10 times of water that you need. So you don't need so much of water. I mean, there's enough and more water. So if there is for an estimation purpose, you can say, yes, there is a decrease of 2%, 5%, but you just are okay with just 50 centimeter of rainfall. And we are getting already 120 centimeter of rainfall.
Most excellent. Thank you so very much. Thank you so much for the presentation today.
Great. Thank you. Marcus.
Yes, thank you. Professor Nayak, I find your initiative precious and the results are impressive. Now, you are really showing how the interaction of water and food function and what you can do, and one sees you have done something with it. Now, very often I see the label water or nexus of water, energy and food. So I see the connections between what you are telling us and the energy aspect are everywhere. But my question is, if you can do a meaningful study of all 3 aspects in one and the same project.
Your voice has gone off. The last 1-2 lines couldn't hear.
My voice? Oh, yes. Okay. I think taking on a project that was to treat the whole nexus of all three aspects. Does it lead to a meaningful research? Can you do meaningful research within one project?
Well, actually, it's like the Sun project. It's a very complex exercise. So it requires. I mean, that's why for the last 2 years, although we have funds for small projects from different agencies, but I've been trying to get to the government, because unless the government or the whole system really appreciates it and does not disturb it, it will not take off. But our efforts have been, of course, now we are looking at ecology. The focus is on ecology. So which is where your energy flow and mass flow will be handled within a habitat. So, but this requires, as I just want to show you the amount of, we all understand, but just to highlight that point, that the number of, are you able to see this?
Yes.
Yes.
Yeah, so if you see, when you talk about these 8 dimensions, it's actually possible to engage in under this regenerative ecosystem design. This includes all these 40 factors. But this requires enormous engagement, or rather support, from those factors which disturb the environment the most, which is the governance and institutional mechanisms of the government. So you have to get to there, because once they put subsidy, it disrupts the whole process. The incentives and subsidies disturbs the whole dynamics of that ecosystem. So the key stakeholders have to kind of have this awareness, and we have to kind of understand the science of how things work, because they also are interested in solving water problems, food problems, all kinds of problems. They have only problems. Their expenditure is going up as a percentage of revenue. All government's expenditure are going up, and there's no way for them to actually reduce it, because we are becoming inefficient. So this awareness of how to look at the system and how to redesign it, and depending on the choices that we make, we will see the results. So it is doable, but it's, as I said, it's like a Sun project. It's maybe more complex than a Sun project.
Thank you. Very insightful.
Thank you. Are there any other questions? We're coming up to the top of the hour, but we probably have time for another question if someone has something or a comment. Pavel.
Yeah, hi, thanks. And thanks so much, Amar. I'm
Hi.
glad to be able to join you here. And I'm fortunate to have been able to visit that farm, and it's amazing to have seen in person the success that you've had. And it's the 6th year this year now, I think.
Yes, 2016. No, it's more now. It's yeah.
But it's great. And so my question, you might know what it might be already, but just obviously this presentation and your focus is really on the agriculture and regenerative agriculture and soil health processes. And you suggested a little bit, and on some of your slides, I know this is the case, that it's not a closed system, and you're looking at the connection between the soil health and, say, community health and organizational health and structures of the state, for example. And I just wonder if your research, or if there's any funding to look more explicitly at those connections of how the regenerative agriculture helps to support cultural health and community health and sustains cultural identity. If you could just speak to that a little bit.
Yes, not really exactly on that, but it will depend on what kind of proposal I write. Usually NABARD has been pretty kind. Most of the time they do give. For the last 15 years, they've been supporting in different ways. Currently, we are doing one which is university funded, which is fraternity and diversity. So we're looking at the notions of diversity in nature to understand fraternity in social systems. But this is already being funded by the university. So it's very fascinating to see that the relationship between these two. And that when you look at farm systems, the interconnection and interdependence, you can actually see that both are interdependent. It's not that one is necessary than the other. So if the same logic is then brought into social systems, well, we are just trying to figure out how it works. And we're looking at the protest groups, we're looking at different protest groups as why do they come together? What is the reason that they come together? Which kind of protest groups stays on, which breaks out? What is the intentionality of their coming together? And how does nature operate? How do human beings operate? So we have one of this study on, but again, it will depend on how we write the proposals. And I think the time is on for people to actually we are late behind time, as we all know, that these are issues to be resolved. Yeah, we passed time, but it's good luck for all of us if you don't listen to each other.
Great. Thank you, Amar.
Thank you. All right. Well, here we are at the top of the hour. It worked out perfectly. Thank you once again, Professor Nayak, for joining us this morning or this evening, taking time out of your evening. I believe that everyone on this call has your email address and a copy of your abstract and knows where to find you if there's any follow-up. And with that, I think we can say goodbye for today. And
Thank
I'll
you.
stop the recording. Thank you.